Welcome back. We're going to do an example of finding intervals of concavity and inflection points. So here's the example. Let's consider f equals to 3x to the fifth minus 5x to the fourth plus 1. And we want to find intervals where f is concave up and concave down. Plus find the inflection points. All right, so this is all about the second derivative. Remember, second derivative positive, concave up, second derivative negative, concave down. And where the function changes, the second derivative changes sign is where you get inflection points. So we need all the derivatives. So f prime, 15x to the fourth minus 20x. F double prime, what do we get here? 30, 60, x cubed minus 20. Let's factor out, this should have been a cube here. So this should have been 60x squared. So we end up with 60. We can factor out an x squared as well, and we get an x minus 1. All right. Okay, so that's the second derivative. We care about the sign of it. So we're going to do a similar technique that we did with the first derivative. We know the second derivative is going to be 0 and at 1. So the second derivative is 0 here and 0 there. Remember, the second derivative is x squared, x minus 1, and so forth in each of these intervals. I'm ignoring the 60 because it won't change the sign. Now, for x's over here, x squared is always positive. In fact, x squared is always positive everywhere, so let's just record that. Now, for x's over here, the x minus 1 will be negative. And for x's in this interval here, well, x minus 1 is still negative. But finally, when x is bigger than 1, when you subtract 1, it becomes positive. So the total signage over here is a minus, minus, and a plus. So if we record the second derivative signs, it's a negative, negative, and a plus here. The second derivative is 0 in between. Now, you see in these two places, the second derivative is negative, so it's concave down. This means that the function is concave up because the second derivative is positive. And you notice here I switch signs from negative to positive, so this is actually an inflection point. This is not an inflection point because I didn't switch signs. I stayed negative before and negative after. So the answer will be f is concave down on, let's see, minus infinity all the way up to 0, and from 0 up to 1. And it will be concave up on, let's see here, I guess this point is 1 here. From 1 all the way out to infinity. And I'll have an inflection point at x is equal to 0. And that's it. Ciao.